Good afternoon or good morning, wherever you are, and welcome to the Green Road webinar series. So this webinar series discusses cross-cutting dimensions on decarbonisation, climate resilience, water management, biodiversity, disaster risk reduction, construction materials, and inclusive growth for developing green roads. These webinars are anchored in the ADB Green Roads Toolkit and Assessment Tool. My name is Rebecca Stapleton, and I'm a Senior Transport Specialist at the Asian Development Bank and one of the project leads for the Green Road Toolkit project. Today, our webinar will focus on the topic of greening roads for a low carbon future. So we'll be looking at what works and what to avoid and discussing things like how we can make sure our road projects are best aligned with the Paris Agreement and other important conventions and the Sustainable Development Goals, of course. We would like to ask that you please place any questions you have in the Q&A box at any time throughout today's presentations, but please keep your microphone muted unless you are invited to speak. One other thing just to note is that after today's session, the presentation will be uploaded to the Development Asia website for the Green Roads webinar series. So we'll place that in the chat box so that everyone has that link as well. Without any further delay, I will hand over to Ian, who will be moderating today's session. Thank you.
Thanks, Rebecca. And it's my pleasure to be the moderator today's session. I'm coming to you from New Zealand, and I'm working closely with Rebecca and the wider team that she's within. We've got two very well qualified speakers today from Ricardo Consultants to cover the topic. There's been a few slight changes to the speakers from what may have come out on an earlier post that you may have seen. Apologies for that. We've been all over the place in terms of the ADB team on missions around the world. So I will actually introduce formally both the speakers. So the first speaker is Andrea Dell'Uglio. Hopefully I've pronounced that broadly correctly. And he holds the title of Associate Director and the Innovation Lead in Ricardo's Sustainable Transport team. He has 13 years of professional experience spanning various roles in international transport consultancy firms and infrastructure developers. He's worked in numerous countries across Europe, North America, Latin America, and Asia, and has expertise in infrastructure sustainability, digitalization, demand modeling, road safety, deployment of digital products, and innovative solutions to improve transport efficiency and reduce emissions. Quite capable of handling this on himself, but even more ably supported when we have our second speaker is Kadam Lokesh, who is a transport and infrastructure lead within Ricardo and is one of their senior transport lifecycle assessment experts. She has over 10 years of experience in environmental impact assessments of products and services from a range of sectors, although she does specialise in transport. I've noted her CV, of course, is that she's actually worked on multimodal transport solutions, and I think that's a nice way to look at how we're going to get through to things in the future, is not just looking at it from a roads or from the rail or maritime. We've got to actually get all these things together. And she's had her findings from her work. She's presented that at the COP26 summit in 2021 and is a lead author on numerous publications on the topic. So today, as Rebecca said, our speakers are exploring the issues around climate and environmental challenges of road projects and how to ensure these projects contribute to economic growth while being inclusive, resilient, and environmentally friendly. I will put a slight caveat here that what they are proposing and what they'll present may not be 100% aligned with ADB internal processes and rules around Paris alignment and the associated aspects of climate financing. But the fundamentals remain the same, and we actually think it's really good to have that wider view and different perspectives of how we can, as a global community, meet the Paris challenges ahead of us. So with that, I'll pass the virtual floor over to you, Andrea and Kadam, and you can show us the path to a greener and more resilient transport future.
Thank you. Thank you so much for the introduction. And yeah, I think to restate and to reinforce your point, completely agree. You will see that some of the things that we are going to go through might be slightly different, coming from a slightly different perspective. But the idea is this one, to share experience, to share our point of view, also experience in other countries, so that we can enrich your discussion and hopefully provide useful information. I don't know if you can see my screen well.
Yes, yep, excellent. Carry on.
Okay, great. Okay, so let me get started. Okay, so yeah, we'll start from the general, and then you can see we'll go more specific with some example and that we think can be helpful, and aspects that we think should be considered when talking about infrastructure. So the starting point, very high level, we know that the transport sector is a large contributor of CO2 emissions all over the world, and countries are struggling to meet their decarbonization pathways due to a variety of challenges. The first one relates to the complexity that arises from environmental regulations, reporting requirements, and the different framework across region. So while progress has been made in the recent years, navigating this complexity is essential to scaling up climate action. The second aspect is the technological complexity behind the energy and environmental transition to low and zero emission, which requires addressing the transition of the full supply chain, which is complex, heterogeneous, and where many times sustainable solutions are still more expensive than traditional methods. So it's really important to acknowledge this complexity if we want to solve the problem, even if in many cases technologies are there or are close to be there. The third point relates to the complexity of achieving this energy and environmental transition while ensuring that aspects such as resilience, justice, and inclusion are accounted as well. This is challenging as transport projects involve different communities and stakeholders with sometimes conflicting interests. That's the case because these are complex projects, and this project involves a lot of the territories and stakeholders. So ensuring fairness and equity in climate action therefore requires an extra effort and a deep understanding and respect for the local context and the social needs. So jumping to the next slides, I will just take a minute to explain that basically the mission of our company, Ricardo PLC, is precisely to contribute to solving these challenges and allowing this transition by helping governments to align transport policies with environmental and climate goals and develop mitigation and decarbonization strategies. Additionally, we support the design and operation of transport infrastructure, considering the full life cycle of emission associated to this project, as well as identifying and accounting for climate risk and resilience. Kadam will tell you more about this aspect in the next slide. As an example, we are of our contribution to green infrastructure. We are one of the independent verifiers for the Blue Dot Network infrastructure certification scheme promoted by the OECD, whose objective is to promote sustainable transport investment all over the world through the verification of project compliance with economic, social, environmental, governance, and development criteria. So really a comprehensive assessment of all the aspects surrounding infrastructure. Lastly, Ricardo PLC has also significant expertise in quantifying both current life cycle transport emission and forecasting future emissions for different types of vehicles, powertrains, and propulsion technologies, which we use to develop net zero pathways in different geographies. Our results inform governments' transport investment decision, as well as private companies, in fully understanding the impacts of different vehicle technology and plan the decarbonization efforts accordingly. We deliver the above and many more services, I will say, through a team of 3,000 employees, including engineering, economists, policy experts across 23 countries with 11 offices in Asia. Most of our environmental specialists environmental projects are delivered through as consultancy services, but we also offer engineering certification and digital solutions. And another strength that I think is particularly important for the topic that we are going to discuss, and you will see it through the presentation, is that we provide cross-sector expertise. So we do have CADAM and IR transport expert, let's say, but we are surrounded by colleagues with expertise in other fields of environment, industry, and the energy sector. So we can really support, and we really support clients in taking the full scope of the issue and the full value chain of the projects. So without further ado, I will leave Kadam, the floor to Kadam, so we can start going into a little bit more detail about the specific topic of this chat now that I've set the ground and presented our company and our key characteristics and projects.
Excellent. Thanks, Andrea, for kind of setting the context and the introduction, and also an introduction to Ricardo. Hello, everyone. I'm Kadam Lokesh. I'm a transport infrastructure lead at Ricardo. So today I'll be talking about the significance of Paris alignment, help with the problem definition and some pointers on where the gaps are, what needs to be considered to take the next step towards the end goal. But for this presentation, we are going to take a bit of a funnel approach, if I may say so. So some of these aspects, maybe something that you're already familiar with, but for the benefit of everyone, I would like to echo your views here a little. So Paris alignment is a critical kind of climate mitigation strategy in this day and age of climate emergency. So Paris alignment, or Paris Agreement, provides this kind of overarching, comprehensive framework for global action on climate change. It enables nations to come together towards a sustainable future. And these agreements tend to trickle down into NDCs, or nationally determined contributions, which partition what those climate contributions should be from countries based on their existing or new national policies and net zero commitments, if they have one. This then trickles down further into sectors. And you may also have noticed most industries are now adopting science-based targets towards a long-term sustainability for themselves as well. So there are individual efforts that are also happening in this space. Where we often find that major gap is when interpreting those particular contributions needed to sectoral perspectives, because there is often an imbalance in terms of the climate focus on specific sectors. Like, for instance, you may have noticed that the energy sector gets all the limelight, as opposed to other sectors, like to be more specific, industry or transport. Next slide, please, Andrea. Perfect, thank you. So climate change is inevitable, but there is the rate at which the climate is changing, again, is influenced by our actions and inactions where needed. So global mechanisms like Paris Agreement trickling down to NDCs, net zero goals, and science-based targets are absolutely essential to not just ensure that newly built infrastructure contributes positively to the environment, but also ensure that it's future-proofed. We can already witness how human activities like deforestation or urbanization and continuous dumping of those global warming gases are interfering with the climate patterns and permanently altering the critical natural carbon sinks like forests and the oceans. This was recently in the press as well, as to how forests across the world are struggling to absorb CO2 emissions from the atmosphere. There was barely any absorption that was noticed last year because of those disruptions to those biological cycles. We experience the impact of those inactions as amplified weather events like persistent and ever-increasing heat waves all across the globe, and also tropical cyclones that batter the coastal regions all across Asia, like like the cyclone Dana, which is battering my hometown as we speak. So there is still time to act, but there is a need to adopt more comprehensive set of measures. And more importantly, it has to be implemented in the short term. So how do we do this? Where does the problem lie? So yeah, let's take that funnel approach to define this. Next slide, please. Thanks, Andrea. So according to the Climate Action Tracker, 195 countries signed Paris Agreement in 2016. And among them, only 69 countries have updated their NDCs. And for information, NDCs need to be updated every 5 years. So according to IPCC's 6th assessment report and other climate analyses, even if all of these 195 countries were to fully implement their NDCs, we will still fall short of reaching our targets to keeping global warming within 1.5 degrees. Why? Because there is a huge gap between the expressed mitigation policies and the actual implementation of it. And this is fueled further by, more global issues like the political will to action, systems barriers like the financial implications of adopting those interventions. We are limited by the technology of our time and this continued dependence on fossil fuels as well. So if we were to interpret these issues to sectors, specifically transport, like you can see on the right-hand corner of this slide, the IPCC report also goes on to highlight how total transport emissions from Asian territories contribute to nearly 1/3 of all greenhouse gas emissions from the region. You may have seen this a number of times from the previous presentation. Again, 75% of those emissions come from road transport. The report suggests that, infrastructure emissions, as in the embodied carbon in these structures, present only a small contribution of those overall emissions. However, with the increasing frequency of the extreme weather events, like I spoke of, there is going to be more need for, there's going to be frequent repairs or even reconstructions required. So contemporary frameworks that are applied for build or no build decisions on those assets need to cater for projects' performance over the assets life cycle, accounting for these different climate risks as well. Otherwise, we risk cumulatively adding more emissions to those emissions that are reported as it is. Secondly, over the course of this presentation, we will need to acknowledge that infrastructure is an enabler of those emissions. I'll tell you why. Next slide, please. Thanks, Andrea. So like IPCC have reported this wider prevalence of carbon lock-ins across the world. This is a major issue, particularly in developing nations. So what is a carbon lock-in and how does it work? So we have roads, expressways, flyovers, which are carbon-intensive assets. The concrete, the cement in them, steel used in them, all get introduced into urban and suburban areas to add capacity to ease traffic congestion. And then over time, over their life cycle, from 30, 40 years from their period of construction, there is a kind of a socioeconomic dependency created, somewhat of an addiction created for those structures and those communities. Yes, there is a boost in economic growth. Yes, there is a boost in productivity, and the communities around those infrastructure are flourishing economically, but there are also rising health and well-being issues, particularly from those release of particulate matters and volatiles from the vehicles using those infrastructure. The problem here is that the health concerns and the economic losses associated with them are often decoupled from the more finance-based economic growth and productivity indicators. But this is a part of people's lives now, and there is a change in the behavior which is causing an induced demand, leading to more congestion. And then further down the line, further down the years, there is a need to expand these infrastructure to boost capacity. And before you know it, all of it becomes a kind of, an unstoppable vicious cycle. I mean, this doesn't mean that we need to stop building roads altogether, but there needs to be reconsiderations and there needs to be changes made to our contemporary decision-making model, particularly for infrastructure investments. There needs to be a redistribution of investment and building priorities that are founded on robust, sustainability-driven decision-making process. So when I say sustainability, it's not entirely the environment-centric, but it is also from the perspectives of social and economic indicators. Next slide, please. As I mentioned earlier, sustainability is an umbrella term. So what do we exactly mean by it? Like, for instance, when we are looking at return on investment for asset evaluation, we must also account for its positive contributions to more wider targets. We need to ask, if we're going to spend so much money on the asset, does it contribute to the nation's NDCs? Does it contribute to net zero targets, if there are any? Does it contribute to any specific sectoral targets, like supporting route electrification, public transport densification? Does it contribute to pollution reduction targets? Does it account for forest conservation and biodiversity protection? Is it cutting across any kind of wildlife crossing routes? What are its ambition for demonstrating long-term commitments? Like, is it integrating green corridors, wildlife bridges, or kind of stormwater drainage and management structures? And then how inclusive is the infrastructure? Does it contribute to access to healthcare, education, and jobs? Because again, when you look at this, all of this collectively can generate revenue and develop the wealth of that community. The build and no build frameworks must therefore account for these more kind of comprehensive indicators, similar to what the OECD's Blue Dot Network certification scheme is looking into. And from my understanding, what ADB's Green Road Toolkit are also trying to achieve. So it is understandably challenging because of the various dimensions and the many layers of sub-dimensions under them that we need to take into account. There are also loads of interventions to choose from something as simple as deciding to not build the infrastructure through to consideration of more smaller green infrastructures, like integrating nature-based solutions, and more comprehensive mix of interventions that can support greener and future-proofed network of infrastructure. But again, the problem here aren't the options, but the lack of that kind of guiding framework, a mechanism, and the mandates to oversee its implementation to those new projects. There are also the location-based features and stakeholder complexities that add fuel to the fire, similar to what Andrea mentioned at the start of this presentation. So all of those need to be taken into account as well. Next slide, please. Thanks, Andrea. So similar to those frameworks, there needs to be a vantage point from where a comprehensive and inclusive assessment can be undertaken on those assets. But this needs to be done over a project's entire life cycle. I mean, right from the planning phase to the assets decommissioning phase. So even beyond the manage, slice of the pie that you can see in this image. So this is where life cycle thinking can help streamline those kind of really complex thought process under dedicated stages of the asset's development. So the principle of LCT, or life cycle thinking, is to evaluate the economic, environmental, and social consequences of that asset over its functional lifetime. I mean, this is something we apply cognitively to our lives on a daily basis. So this fundamentally reveals those relevant benefits and risks associated with those assets and that proposed design, even before the build decision is made. So starting with the planning phase, this in general needs to create a kind of an inclusive environment where value chain actors like the transport authorities, the construction companies, and the community members all collaboratively voice out their needs, views, and concerns associated with those planned assets. Their intel on local climate risks, the biodiversity impacts, like, for instance, wildlife crossing routes, and also landscape features that can help mitigate those climate risks will be invaluable to the design phase. And then we apply this evidence to understand what environmental, geological, and quality of life trade-offs need to be made for this asset to come into place. So what are the local ecosystem impacts, particularly the short-term pollution impacts that will come from its construction process, the land use change impacts that are associated with these build. So all this can be informed through the site visits, analyzing the local weather and hydrogeological patterns, looking at the local environment. We can also, look to commission a small local environmental impact study, depending again on the creativity of those relevant stakeholders. I understand this sounds all, environment centric, but as I said earlier, we also need to build a business case for the asset because it needs to be able to generate revenue over the time of its functionality as well. So we need to look at those various dimensions of the more inclusive economic growth indicators that I said above, like access to jobs and health and well-being, electrification targets. So in the design phase, we apply all of those findings and we come up with a pipeline of asset designs, accounting for how compatible they are with the location and the identified climate risk. So for this, interventions can be chosen hierarchically if needed. For example, if land is prone to flood, we prioritize nature-based solutions, capitalizing on the local wetlands or nearby basins like natural buffer zones that can act as sink. If the design criteria does not allow for that, then we move to integrating greener infrastructure like permeable pavements if needed before we default to embankments or elevated roads, which are carbon-intensive infrastructure. So once a clear business case has been established and the project go-ahead has been provided, we move on to build phase, which requires, again, optimizing build characteristics, ensuring that the construction stays within the bounds of the financial cost and the risks identified. We want to reduce waste that is generated and circularize those materials as far as possible to keep the financial and the environmental burden to a minimum. Any of those best practice measures that I've listed can be recorded and reported, earning more brownie points, like in the case of performance-based contracts, or in the case of renewal of certification, like what BDN is about to start issuing once assets fall in line. So construction is complete. After this, the monitoring phase enters. So during the monitoring phase, the asset's performance review is absolutely critical, particularly when extreme weather events are becoming more and more frequent. We need to optimize the functional characteristics of the asset to the likes of the wear and tear from the local weather patterns. This again comes from those steady monitoring of the asset's performance. So the data that we gather from the operational phase could support predictive maintenance, which is a more efficient form of maintenance regime. We can implement retrofits or upgrades as we see fit, but the ultimate goal here is improving the functional longevity of that asset. So there is the transport infrastructure asset maintenance, but we also need to look at the health of the ecosystem where this asset sits. So the nearby buffer zones like bioswales or those basins, they will need to be checked for any pollution leakages or blockages and ensure that any kind of remediation attempts need to be made as promptly as possible to prevent further damage to those assets and the environment. So the goal here is to ensure that the roads are Paris-aligned if need to be constructed. And while you're at it, you get the bang for the buck with these long-term assets serving their true service life. And then they are resilient to the climate risks identified as well. And more importantly, they don't just fulfill the transport needs of two destinations, but they contribute to multiple sustainability indicators as well. So thank you for listening. Now, Andrea will summarize on how these various aspects that I spoke of could be accounted into the principles of those framework, and then, particularly when analyzing infrastructure projects. So thank you for your interest so far.
Thank you, Kadam. So yeah, Kadam made a good job, I think, to provide a comprehensive analysis of all the challenges, all the things required when analyzing a project and considering the full life cycle. Now I will focus a little bit more on some more detailed aspects and trends that needs to be taken into account when analyzing infrastructure projects, but starting from something a little simpler and then moving into some more detailed consideration. So traditionally, road infrastructure, this is a simplified, of course, view, but I think it's helpful as a starting point. Traditionally, road infrastructure projects are analyzed through cost-benefit analysis. Sorry for that. Through cost-benefit analysis that compare project CapEx, OpEx, and to some extent environmental costs against social, economic, and environmental benefits when we see those. where generally among the most important benefits we have travel time, particularly in congested area or in areas served by slow or poor condition roads. The cost-benefit analysis of a road project, however, needs to be complemented by an initial evaluation of its alignment with strategic and climate goals, keeping into account the context and climate risk of the region, as well as the synergies with existing and planned infrastructure projects. And we cannot consider a project as it didn't, let's say, relate to the rest of the planning and wider context in the society and in the city or region. So this initial evaluation plus the cost-benefit analysis needs to be also followed or run in parallel, let's say, with a wider social and climate impact of the road projects to assess. This shall include the analysis of the extent to which the project improves connectivity and accessibility to transport and services across the region, with focus on unserved community. Inclusivity also needs consideration. As an example, we can think about a toll road, for example, and inclusivity measures could include toll exemption to residents or to low-income workers in the region that could really ensure that this toll doesn't become an issue in terms of inclusivity and social justice. Finally, the impact of the project on the local ecosystem and its ability to withstand extreme weather conditions need to be accounted as well, as Kadam has already explained. If a project ticks all these boxes and more, we could discuss some of them in more detail, then there are very good chances that the planned road is going to be strategic for the region, make sense from an economic sense, and also provide the environmental, social, and climate benefits to its region of influence. So in the next slide, I will focus on a few, I think, interesting aspects and trends to consider when carrying out this infrastructure analysis, as they can change the result of the assessment, particularly for projects with large lifespan, like, I don't know, PPP project with long concession period that really needs to look forward to, I don't know, 30, 40 years, depending on the geography. The first aspect I want to discuss, which is important to account, and Kadam touched on it quickly in the previous slide, is the importance to acknowledge the importance of demand modeling, and particularly capturing the induced demand by road project. This is important since when a new road is open to traffic, the first and more visible effect is the reduction of travel times, and generally also reduction of congestion in the alternative roads, since part of the traffic now uses the new asset. This effect provides social and economic benefits to travelers, thanks to the time saved, productivity benefits for the region, which benefit local economy, and potentially also some environmental benefits, as stop-and-go traffic is reduced, and as such, the average fuel consumption per vehicle tends to reduce compared to the situation before the project. However, as improved travel condition can lead to additional traffic, particularly over time, as existing drivers tend to perform more trips and kilometers now that the travel time is lower. People are incentivized to buy a new car, particularly in countries with low car ownership, or switching from public transport to private vehicles, thanks to the higher comfort and lower travel time. So the emissions associated to this additional traffic, in many cases, offset the environmental benefit related to the lesser congestion. The effect obviously varies based on the location of the road, being less critical generally in rural environment where congestion levels are lower. However, it's still worth remembering about this effect and accounting it properly, as an underestimation or an overestimation can completely change the results of a cost-benefit analysis, and as a consequence, the evaluation of a project, particularly in areas where a lot of roads and infrastructure needs to be built, and we really need to find the right priorities. The second interesting aspect that I wanted to highlight here is which is important when carrying out cost-benefit analysis for infrastructure projects, is the expected evolution of the fleet in the years to come, as this can be analyzed as far as mitigating the impact of additional demand on emissions. As an example of this effect, in this slide, I show the estimated penetration of EV sales in the European Union up to 2050 under different policy and technology scenario, with the most optimistic scenario forecasting a 40%, you can see it here, forecasting, I don't know if you can see the pointer, a 40% penetration of EVs on total vehicle sales by 2030 and reaching 100% of EV sales by 2050. Of course, this is one of the positive scenarios. Others have been developed based on different policy strategies and technology also readiness. Under this scenario, this optimistic scenario, life cycle CO2 emission are forecast to reduce by more than 50% in 2050 compared to the base year, although this will obviously depend on the actual implementation of the policies promoted by European Union and the member states in the years to come. In the table to the right, you can also see that in addition to full electric vehicles, other technologies are expected to increase their market share over time, particularly hybrid and plug-in hybrid vehicles, which aren't zero emission, but still less polluting than typical internal combustion engine vehicles. So both the charts included in this slide focus on Europe and are based on a model developed by Ricardo, that has been used to support European Climate Foundation in understanding the impacts of different greenhouse gas emission policies in order to inform a policy subsidy decision in Europe. Even if these findings for sure will be different for Asian countries, the message that I want to convey here is that this type of long-term energy efficiency assumptions need to be included in the cost-benefit analysis, need, of course, to be realistic, to recognize local peculiarities and challenges, but needs to be there because they can completely change the way an infrastructure project is assessed and its benefits, particularly in terms of environment. As vehicles become more and more green, putting more vehicles on the roads, if you want to simplify, is going to create less problem from an environmental standpoint, even if, of course, congestion problem is another matter because an electric vehicles require the same use of space as a diesel vehicle, but still on an environmental standpoint, we believe that it's very important to take into account this macro trend and build realistic scenarios country by country in order to ensure that we can evaluate well infrastructure project. Of course, we cannot talk about electrification, decarbonization, if we don't talk about charging infrastructure, because the ambitious electrification scenario that we see in the previous slide cannot materialize unless charging infrastructure is deployed, both at depot, particularly for bus and commercial vehicle fleet, but also on the public road infrastructure. This means that when planning, designing, and procuring road projects, EV charging stations need to be considered as an element of the project, particularly in rural area where EV autonomy is unlikely to be sufficient to allow for depot-only or home-only charging. This is particularly true in a region like APAC, where, according to the Asian Transport Outlook, 8 million kilometers of road will need to be built by 2030. And as a consequence, we really need to plan this road in a way that will enable the transition to electric mobility in the decades to come. On this point, I'd also like to underline a couple of aspects and challenges related with the selection of the right location of each EV charging point. The first one relates to the availability of sufficient grid capacity and the potential complexity of the connection of the EV charging point to the electric grid, particularly for high-speed charging, which will be critical for light and heavy-duty vehicles, for both light, but even more for heavy-duty vehicles that require higher charging. power. Our experience in different geographies suggests that the time needed to obtain approvals and execute this connection to the grid can take significant time, and selecting the locations in areas with good grid capacity or easier connection can be extremely beneficial. So it's like a new constraint, a new element that need to be taken into account, because traditional gas station didn't have this problem. You need to look the connection to the pipeline and the fuel supply, but they were not large electricity contributor or user of electricity. Now with planning for EV charging, increase the complexity and force us to look at other characteristics like the grid connection, for example. The second aspect relates to the possibility to generate renewable energy to power EV charging points, potentially requiring the installation of battery storage system to store the energy generated by the solar panel during the day and use it to charge EVs at night or during cloudy weather. Alternatively, system without battery storage can be deployed as well, where the surplus energy generated by the solar panel during the day is fed back into the grid in exchange of credits or payment. This mechanism is called net metering. And in this case, when solar generation is not sufficient, the charging point draws energy from the grid to charge the EV. Either way, and we can have a longer discussion about what's the best solution depending on the context. But either way, ensuring that the EV charging location is suitable for installing solar panel for energy production, as well as is located in a place where there is a good grid connection, is another important criteria to consider when planning EV charging infrastructure, and is going to be an enabler of whatever optimistic scenario in terms of EV adoption in the years to come. Another aspect that I would like to consider, which I think it's important to consider when analyzing infrastructure projects, is the cost of carbon, as it can significantly affect the cost and benefit of a road project again. As we can see in the chart to the left, the x-axis shows the carbon price, the y-axis shows the share of the region's emission covered by carbon pricing, and the size of the bubble shows the volume of emission in each jurisdiction. To better interpret the result, we can look, for example, at the European Union emission trade system. You can see it here. That is a cap and trade program designed to reduce greenhouse gas emissions across the EU by setting limits on emissions from sectors like power generation and heavy industry, including steel and cement, that are relevant for the road sector. Companies can buy and sell emission allowances with price determined by the market and fluctuating based on supply and demand. In 2023, the average carbon price for industry under EU ETS, as you can see here, was around $90 per metric ton of CO2 equivalent, covering around 40% of the region's emission. This is just an example. As you can see in the chart, there are different schemes in different geographies that cover with different prices and covering different percentages of the total market. However, I think that what's important here is not only the complexity of the scheme, which I think is important also, going back to the difficulties to align policies, but also to the expected evolution, because the consensus is that carbon pricing are going to increase in the future as governments are willing to incentivize the adoption to zero carbon technologies in various economic sectors. So again, this slide is meant, shows example from different countries, and I made you the example of EU ETS, which is an European chart, but still, the underlying message here is that we need to take care about carbon cost and analyze, when analyzing infrastructure project, try to forecast its evolution, because the result of the assessment is going to be different based on the assumption, and the rules that are going to change. So I think this is another important aspect to incorporate in a project and infrastructure assessment. So these were a bunch of aspects. We could mention many more, but I think are interesting thing always to keep in mind, and also the importance of remembering that when we evaluate road projects, the situation is continuously changing and going to change. Technology will keep evolving, policy will evolve as well. So we really need to be able to forecast in the best possible way in order to ensure that our evaluation makes sense also in the long run. To conclude, Kadam, do you want to maybe go through the conclusion since I've spoken too much?
Yes, thank you, Andrea. Truly appreciate you setting the context in terms of more specific approaches that could be undertaken. So, this is going to be very much a summary of what we spoke of earlier. So road projects have to analyze the greenhouse gas emissions, as I mentioned, from a life cycle perspective, because implementing sustainability into infrastructure, again, depending on how complex they are, could be, a very monumental and resource-intensive task. But life cycle thinking can help to some extent streamline some of those complex processes. And, I'm a life cycle assessment expert, so I have my inclinations towards recommending that the more wider environmental impact, like, the air pollution, soil pollution, biodiversity impacts, all of those need to be accounted for as well on top of greenhouse gas emissions. But even if we can look at CO2 emissions for a start, that is a really, really good starting point. And then in terms of the decision-making frameworks that we spoke of, the build and no build decisions, as I mentioned earlier, these frameworks need to be based on a strong foundation of sustainability indicators. So we are not just referring to the environmental ones, but also in terms of the socioeconomic benefits these could bring, not just to those communities living close to those infrastructure, but also to the relevant stakeholders like the state governments, the transport authorities, the companies operating and managing those infrastructure assets. Everyone could benefit from this, but there needs to be a kind of a collective positive reinforcement of those viewpoints into those decision-making framework. In terms of the project's assessment, yes, we need to ensure that the road projects are aligned with, Paris Agreement if they need to be built, and they need to be supported by a kind of a more progressive, cost-benefit analysis that accounts for these various sustainability elements that we kind of considered. So thank you so much for your time, and we look forward to your questions.
Thanks, Andrea and Kadam. There are a couple of questions there from one, but I'm going to use my privilege as being the moderator to ask my own question first, because I think that's the benefit of being the moderator. And if I look across the reports, everything seems to indicate we're not on track to meet the Paris goals. And if we look from a transport point of view, the top 15 countries produce 60-odd% of the emissions. What's the advice then to a smaller country, but with a lot of poverty, and really facing that challenge of, do I invest in trying to convert my network to electric, or do I accept the rest of the world is not doing enough and I need to just spend my money on preparing for the inevitable? Like, at what point do these small countries, are they better off to give up trying to change and actually deal with the consequences? Either of you, if you have a view or a
I'm happy
thought.
to take this on. Yeah, I'm happy to take this on. Thank you. So it is a very good trade-off, a very good thought process. Again, they're imagining things from the life cycle perspective. So what serves their benefit the best? So it's a very valuable viewpoint to have. And it is understandably so, because as we mentioned earlier, the NDCs aren't efficient enough at this point. But that said, I believe the costs of inaction is going to be outweighing this thought process that is going through this hypothetical person's head. I believe there needs to be, a bit of a trade-off that needs to be made, and some of those efforts need to occur from, top-down perspective. There needs to be awareness raised about the wider collective economic and environmental benefits that, the different stakeholders from across the, value chain that are involved in the assets management could reap from. I'm talking right from, the governments to transport authorities, to the communities that are living around those infrastructure and around the environment surrounding that infrastructure. Perhaps adopting a kind of a pilot scale study to demonstrate those benefits to a greater extent can help them view the benefits that come out of implementing, Paris-aligned roads, for example. That's a good start. Plus, to some extent, there needs to be commitments coming from the governments in terms of incentives towards switching towards, low and zero emission technologies, like, for instance, electrification. These are targets which have been set by governments even in those countries. I think there needs to be a push for that. So there needs to be a certain amount of, raising awareness and capacity building coming from for the stakeholders, such as, members of those rural community, so they can push for dialogue with the relevant authorities who are involved in these various initiatives as well. So there needs to be a combination of interventions that have to happen both top down and bottom up to enable this.
Okay. Thank you. I'm going to pick up on Wim's second question there about, in essence, why is it all about electric vehicles? And without going into all the details, but I guess rephrasing it is, are you seeing any great initiative or breakthrough of ideas beyond waiting for electric vehicles and maybe tinkering with some construction techniques? Is there anything else out there that's, going to do it for transport, for the want of it? Are we seeing any other smart ideas coming through?
Well, let me answer on the electric vehicles one. Electric vehicles are part of the solution, even if they are not a solution that can be applied. I saw the question and it raised very good points. Can be applied without thinking, and the full supply chain, let's say, the critical material that is used for them, how this material come from countries with sometimes at times slavery problems. So I think it's a very proper point. So electric vehicles need to be considered properly, and we cannot just look at the zero emission at the tailpipe. We really need to see where this electricity come from. And so if you charge your electric vehicles on a grid, and the energy the way the energy is produced on that grid is not clean, that's a problem. So of course the solution is not just going electric without looking what's behind all the process, both in terms of construction, building the vehicle, the batteries particularly, which is the most critical component, but also sourcing the energy. So that's 100% a concern, and that's why, as much as possible, if we want to take the full advantage of electric mobility, we need to act on how the energy is provided. 100%, I think that's super important. But yeah, electricity is not the only solution. And actually, in the short term, it's going to be difficult to electrify for particularly heavy duty vehicles. We're still not there. Autonomy is not enough. So in those cases, alternatives need to be considered. Some shorter term alternative are low carbon fuels. There are different types of biofuels that can be used that are sourced from different waste products, and that can improve already the situation compared to traditional fuels. This is a temporary solution that is good, particularly for the diesel heavy-duty vehicles. Hydrogen is another alternative, although the cost is still not there, and there are also safety concerns, and probably is never going to be the most optimal option in urban cities, whereas it's much more suitable for longer distance travel on, for example, rural roads, where really the longer is the trip, the more cost effective is the hydrogen technology. So that's another alternative. But yeah, more things can be done. For example, I've recently worked on a project. It was in Europe, but where they were trying, the owner of the highways, well, they were trying to reduce as much as possible all the consumption related to lighting and tunnels, for example, by replacing the current lighting system with LED system, and also, for example, installing solar panel on top of tunnels where possible, so that the energy can be used directly to power the tunnel, because tunnels have high energy usage also during the day. And so the possibility to use that solution without the need to build large battery storage is another thing. So reducing the energy consumption during the operation of the asset, plus making as much using as much renewable as energy as possible, is another way to reduce the footprint of projects in the operation phase, particularly. I don't know if Kadam has had any other ideas.
Yeah, that's okay. We'll carry on because there's a few other questions. I'll just say a shout out here to Charles Malhewish, who was my ADB boss way back in the 90s when we did the HDM4 models and I first started doing modeling of tailpipe emissions, and Charles will be happy to know that all these years later I'm doing the new one, and that picks up the full spectrum of emissions, like you say, going back, but even looking at the manufacturing of vehicles. So when we're doing these investment decisions, we're looking at where is the power coming from, where are the vehicles, how are they being made, so that we get a real life cycle picture, and we can actually say, well, yes, the concrete road has more emissions than an asphalt one in it, but the actual emissions of driving on it are less because it's a rigid structure versus a flexible one. So we want to be able to do real trade-offs. There's a few other questions. One of the ones that I guess I see is, or I guess more falls into the pet peeve of mine, is what I call non-productive emissions. So that's emissions while people sit in queues at toll plazas, sit in queues at border crossings, maybe at a pinch point somewhere. Is there any reporting of that separate to what I would call a productive emission? So for trucks hauling goods from a factory or to a market, yes, there's emissions, but there's something coming of it, versus just emissions for the sake of inefficiency. Does that ever get reported separately?
I don't know your view, Kadam, on this, but I would say yes. I would say that we should differentiate, of course, because there are emissions that come from inefficiencies that really should be the first to be tackled. So, and yeah, I tend to agree with you. I don't know, Kadam, if you want to expand.
Oh, yeah, I don't disagree with you at all on that, Andrea. I believe this creates a rationale really towards expanding those infrastructure. We spoke about how those dynamics, kind of how those mechanisms work together in terms of the induced traffic. While it does yield that short-term reduction in emissions, absolutely, we need to, as I mentioned earlier, we need to bear in mind that the infrastructure, leads to progressive increase in those kinds of unproductive emissions, as you rightly raised, Ian. But I believe this is where Andrea's recommendations on electrification, which is also, rightly seeing a lot of targets being deployed by some of those Asian countries as well, because if induced demand is going to be an inevitable impact of new infrastructure addition, then we might as well be able to alleviate the tailpipe emissions there. Yes, to a great extent, the overall, if you were to look at the, well-to-wake emissions related to those vehicles, again, the carbon intensity of it is determined by, what is actually powering those vehicles, what type of electricity, low carbon or high carbon, depending on the energy mix of those power generation plants. But at least the tailpipe emissions of those vehicles sitting in those queues will be eliminated by electrification. Yes, it is the kind of, it is at the far end for some of those, economically disadvantaged countries that you mentioned at the very start of our Q&A. But that Asia is kind of, rich in terms of resources, particularly in terms of, solar resources and other kinds of renewable energy generation, vectors that way, which could be produced to, power this transition, this low carbon transition, at least in the short and medium term. I believe those can be capitalized in this time period.
Okay, Brendan, you've got your question there about 30% of the emissions in the construction. I don't know what that under in Kadam, but my experience, that would be in a very low traffic environment. If you get into parts of Mongolia, yes, but on most networks I've analysed, the actual construction emissions are well below sort of 5%. And indeed, when we've analysed some projects here in New Zealand, when we've been resurfacing a road, the additional emissions from the tailpipe from vehicles stuck in the congestion is actually higher during construction than the actual emissions that you've put in the road. So realistically, playing with how you build a road is an interesting little side topic, going to make, in essence, no difference to the world. It's not saying we shouldn't do it. We should recycle and reuse and all that good stuff. But it's not going to make a difference. I am aware we're right on time, or right at the end of our time. Just trying to see if there's any. We'll probably try and go back and just answer these questions afterwards on the side in any case. What do you got? Small countries, electricity. Yeah, I think we'll just try and answer the rest of them actually online. Thank you all for the questions. I am aware we need to let you all go. I'd like to thank both the speakers for sharing their knowledge and experience with us. So I'll give you the clap and everyone else can give you the virtual clap. So thank you. I hope you've all enjoyed this, and there will be another session in another 2 weeks. And I can't quite remember the topic of that is off the top of my head, but we will get that out to you all. So thank you. Thank you, presenters, and have a good evening all.
Appreciate it. Thank you for the opportunity, Ian, and everyone who attended the webinar today. Thank you so much.
Thank you.
Thank you.
Bye-bye.